the members under pure compression, okay? So, pag po ang member is under compression, okay, so see our illustration here, okay? So, we have here the machine member, and then you apply it with a compressive load. So, we call this your FC, okay? So, ano po yung tendency ng atin ng member? Okay? So, the tendency of the member is simply to compress. Okay? But then, that is kung yung member po natin ay maikli lang yung kanyang length, and at the same time, the cross-sectional area is somewhat proportional to the length. Okay? Pero, hindi po katulad nung let's say for example, you have there yung ruler po natin. Okay? So, yung ruler natin, so mahaba yung length, and then you look at the cross-section, medyo manipis. Okay? If you try to apply there a compressive load, katulad po nito, makikita nyo po, ang tendency po nung atin na member is to compress. Okay? Compress, but then you would observe there po, nagkakaroon siya ng bending. Okay? So, yung bending po, it is not noticeable kung maikli lang yung member. Pero kung siya po ay mahaba, okay, at tapos manipis nga po yung cross-section, so nagkakaroon ng bending. Okay? So, yan po ngayon yung titingnan natin kapag meron tayong members under pure compression. Hindi po siya katulad doon sa tension. Sa tension po kasi, ano nangyayari? If you apply here a tensile load, FT, so ang tendency lang po niyan is to elongate. Okay, whether the cross-section ay manipis o at mahaba yung kanyang length, parehas lang po yung effect niya doon sa maiikli lang na length. Okay, so lagi lang nagkakaroon siya ng elongation. Pero sa compression po, magkakaiba yung nagiging behavior niya. Okay, so nag-iiba yung behavior niya, depende po sa cross-section at saka sa length ng atin pong machine member. Okay, so basically, different po yun. Okay? So, ano pong ang gagawin natin if we are to design these members? Okay? So, pag nag-design po tayo ng members under compression, we have here po what we call the slenderness ratio. Okay? So, yung slenderness ratio po natin, it is a ratio between, okay, the length divided by K. So, ano po is length? This is the original length. And K, we call this po the least radius of gyration. Okay, so this is least radius of gyration. To obtain po the value of K, K is simply equal to the square root of I divided by area. Where then this I, you call this your moment of inertia, and A would be the cross-sectional area. Okay? So, yan po yung K na least radius of gyration. So, pag tayo po ay magde-design ng member under pure compression, ito po muna yung ating unang kukuhanin. Okay? Let us obtain first po yung slenderness ratio L divided by K. Okay? So, dito po kasi malalaman mo ano yung behavior niya when you try to compress the member. Okay, katulad po ng dalawang sinabi ko kanina. Meron na ma-observe tayo, merong bending, meron naman simply contraction lang. Okay, that is through this slenderness ratio. And pagka po ganun, iba po yung paraan natin para po i-design sila. Iba po yung procedure na gagamitin po natin. Kaya necessary po that we solve first for this slenderness ratio. Okay? Again, L is the length, okay, and K is the least radius of gyration. So, for the value of K, i-derive po natin siya. Coming from the general equation, square root of I over the area. Say, for example po, we have a circular cross-section. Okay, alam mo po, circular yan. What would be the value of K? Okay, so let us recall. Ano po ba yung value ng I? The moment of inertia if you have a circular cross-section. Anyone? Hello? Ano po yung value ng I kapag po circular? Hello? Anyone? What about po the area? Ano po yung area natin if it's a circular cross-section? Yes, Sir Dan?
Pag area po ay pi r squared po.
Okay, pi r squared or say pi d squared divided by 4. What about po naman yung moment of inertia I? Hello?
pi d fourth po over 64.
Okay, correct. Pi d to the fourth divided by 64. Okay, you can see the values of I also. You take a look po at table 81. Okay, everybody, you look at table 81. Yan. Pakihanap nyo po doon sa ating design tables. Okay, open ko po dito. Wait lang. Okay, so this is our table 81. Okay, so yun po, ito yung iba-iba natin na cross-section. And then from here po, pwede po nating makuha yung value ng I. Halimbawa po, this is the circular one. You have here po the value of your I. So tama po yung sinabi kanina ni Aldrich. We have there pi d to the fourth divided by 64. Okay, sorry po yung value. For other cross-section, so let us take a look na lang po at the values of I. So, yun po yung mga equations niya. So, the first four here po, ito pong apat nito, at tawag po natin dito, these are all your regular cross-sections. Okay, meaning, these are regular polygons. Okay, for this, dun sa cross-section natin. Whereas, ito pong dalawang nasa baba, ito po yung tinatawag natin as the economic section. Okay, economic section. So, katulad po nito, this is an I beam. Ito naman po ay inverted T cross-section. Okay? Letter I po ari naman po inverted T. So, may pa pong samples po tayo nitong economic section. So, we could have their letter T, letter C, okay, letter U. Okay? So, yan po ay mga economic sections. So, ang tawag po sa kanila, it's an economic section kasi para po matipid sa material. Halimbawa po ito, nanggaling po siya sa rectangular. Okay? So, ito po ay galing sa rectangular. So, kumbaga, kung rectangular po yan, so you have this area pa po. Okay? So, kung ito yung area na natipid natin kasi inalis natin. O halimbawa, this is made up of concrete. Okay? Ang concrete, meron pong gravel, merong sand, may semento. Okay? So, matitipid mo po kasi itong part na ito, itong area na to, inalis po natin. Okay? Kumbaga, ito lang yung tinira natin, letter I lang. Kaya ang tawag po sa kanila, economic sections. Okay? So, dito po sa table 81, okay, ay ilan lang pong cross-sections yung available. Okay? So, from here, you can find the value of I. Paano naman po kung wala dito? Then, you need to derive for the value of I. Specifically po, kapag economic sections po yan. Halimbawa po, given po sa atin is letter U. Okay? A letter U cross-section. Okay? So, wala naman po dito. Okay? So, you need to derive on your own what would be the value of I, the moment of inertia for a U cross-section. Okay? So, dapat po maalam po tayo. Okay? Kasi yun po yung gagamitin natin to obtain the value of K. Okay? So, balik po ako dito. So, kapag K po, ano po yung value ng I kapag circular? Okay? Pi d to the fourth, okay, divided by 64. Okay? And then, divided by area, pi d squared over 4. Okay? And then, you take the square root. Okay? To further simplify po ito, pwede po ang gawin natin ay we multiply it by the reciprocal nito, okay, instead. So, this is pi, say d to the fourth, divide 64. Pinalitan ko lang po ng small letter, pero the same lang po yun ha. Gawin nyo na lang small letter din. Yan. Pi d to the fourth divided by 64, then multiply po nung reciprocal po nito, 4 over pi d squared. Okay? So, we can cancel out now po yung pi. You have here d to the fourth and d squared. So, may natira po doong dalawa. And then you have there 4 and 64. Ito naman po, this becomes 16. So, the simplified form po would be the square root of d squared divided by 16. And d squared and 16, these are perfect squares. Okay? Perfect squares po. So, kung ilalabas po natin ang square root sign, this will become d divided by 4. So that would be equal to your K or the least radius of gyration. Okay? So again, ito po ay specific lang if we have a circular cross section. If you have a different cross section po, then you need to derive from the general formula K equal to the square root of I over the area. Okay, maliwanag po ba? Hello?
Yes po, ma'am.
Okay?
Yes po,
So,
ma'am.
ari po ay for circular lang po. Okay? So, ano pong sinabi ko kanina? Whenever you design po for a member under pure compression, necessary that you solve for this ratio, slenderness ratio. Okay? So, let us take the case 1. Okay? So, this is our case 1. Okay, this is our case 1. So case 1 is when the slenderness ratio L over K is less than or equal to 30. Then you call it a pure compression block. Okay? Less than or equal to 30. So ang slenderness niya po, yun muna po natin itong sosolvin. Kapag po nakita mo it is less than or equal to 30, then you call it a pure compression block. Okay? Alam po yung pure compression block? Ito po yung mga compression members po natin wherein pag in-apply po natin siya ng compressive force, ang tendency niya lang po is to contract or compress. Okay? Kasi usually po, maliliit lang po yung member natin and then proportional yung kanyang cross-section to the length. Okay? Kaya ang nangyayari po dyan, pag in-apply mo siya ng compressive load, it tends to contract lang. Okay? So, nagkakaroon lang ng pagbabago on their length. Okay? Nagdi-decrease lang po yung original length nila ng bahagya. Okay? So, how do we design these members po? Kapag po alam na natin na siya ay pure compression block, i-design po natin siya na katulad nung sa tension. Okay? Ganon din po yung way natin kung paano po siya i-design. Wait lang. Okay, so we have what we call the strength failure and the deformation failure. Okay, so i-design po natin base doon sa dalawa. For the strength failure po, we call the induced stress. Okay, so ang tawag po natin sa induced stress dito is a compressive stress. Okay, so compressive stress po yan, ang ating pong value ng sigma, okay, is equal to force over the area. Compressive force po yung gagamitin natin. Okay, and then this is the induced stress, and what we do in design is simply we equate the design stress to the induced stress of the material. So therefore, compressive would be equal to the design stress. Okay? So the design stress is equal to what? This can be sigma U divide Fs o kaya naman ay sigma Y divided by factor of safety equal to the compressive force Fc over the area. So, kung circular po ang ating sample, okay, katulad po kanina, kung circular po yan, di yun lang pong area na yun, yan po yung papalitan natin. Okay? So, magiging Fc over pi d squared divided by 4. Likewise, ganun din po ito. Fc over pi d squared divided by 4. Ari po ay gagamitin natin, okay, yung design stress po na sigma u over Fs, gagamitin po natin yan if design is based on the ultimate. Okay? At rin naman pong isa ay gagamitin natin if design is based on yield. Okay? So, galing po dyan sa equations na yan, you can solve for a dimension or say a diameter. Okay? Yan po yung sa strength failure natin. Okay? So, parehas lang po yan noong sa tension. Ano lang po yung pinagkaiba niya? Instead of using a tensile load, edi compressive load po ang nandito. Okay? But then, basically, the procedure would be the same. Equating the design stress to the induced stress of the material. Okay? Likewise, we have also the deformation. Okay? So, sa deformation naman po, anong tawag natin sa deformation na meron po yung member natin? Ang tawag po ngayon natin sa kanya is contraction. So, that would be a decrease in the original length. Okay? Kung dun po sa tension, there is corresponding elongation. dito naman po, contraction po ang meron po tayo. Okay? So, what would be the equation for the contraction? So, contraction would be equal to FL over area times A. Okay? So, the same equation po, FL over AE. Ngayon lang po, ito po ay contraction. And just the same for a good design. Ano naman po yung i-equate natin kapag deformation failure po ay consider natin? It is the allowable limit of deformation equal to the contraction. Okay? So this would be equal to FL. Ang area po, if it's circular, that becomes pi d squared over 4 and then E. So lagi lang po yung A po yung pinapalitan natin. Titingnan nyo po kung ano yung cross-section niya, then that would be this, yung pong equation para sa cross-section na gano'n, sa area na gano'n, yan po ang sasubstitute natin dito. Equal to the allowable limit of deformation. Okay, so we can have here another answer. Okay, galing po sa deformation failure. Okay, so again, hindi po palaging may deformation failure na solution po tayo. Okay, yan po yung magkakaroon lang if you are given this, the allowable limit of deformation. If this is available, then you can solve for the value of the diameter. Okay, so here you yield two answers. One coming from the strength failure, the other one coming from the deformation failure. Okay? Alin po sa dalawa ang gagamitin? Hello? Alin po sa dalawa yung gagamitin? Dalawa po yung naging sagot natin.
Yung mas mataas po, yung mas malaki po.
Okay, yun
Mas
po
mataas po.
mas malaki. Okay, correct. Kaya po lagi din may note. Choose whichever is bigger. Okay, to satisfy both strength and deformation failure. Okay, yun po ay kung parehas po na present yung dalawa. Pero kung wala naman po ibinigay sa atin na allowable limit of deformation, ibig sabihin, wala po itong solution na yun at ang solution po natin ay base lang dun sa industress lang po. At kung ano po yung sagot natin dito, and then that would be our final answer. Okay, you need lang po to convert it to the commercially available size. Okay? Nakuha po ba? Hello? Okay, good. So, hindi ko na po masyadong hahabaan yung discussion doon sa case 1. Again, parehas po yan doon sa tension. Ano lang po ang pinagkaiba? Sa halip po na tensile force, ang ginamit po naman dito ay compressive force. Okay, FC. And then, sa halip po na elongation, yung deformation niya, ngayon naman po is a contraction. But then the procedure, it's basically the same. Okay? Designing against the strength failure, and then the other one is designing against the deformation failure. Okay? So, that would be our case 1. So, yan po yung procedure na ina-apply natin kapag alam po natin na case 1 po. Okay? Pure compression block yung member po natin. Yun po ang ibig sabihin ng case 1. Okay? And having a slenderness ratio L over K less than or equal to 30. Okay? So, yun po yung procedure. The second one. Okay? So, ito naman po yung atin na case 2. Okay? This is case 2.0. Okay? So, ano mo naman yung case 2? Case 2 is when the slenderness ratio is in between 30 and 120. Okay? So, it is greater than 30 but then below 120. Okay? So, yan po ang tinatawag natin ngayon as the intermediate column. Okay? So, ang tawag po sa kanya, it's an intermediate column. And when we say intermediate column, how they describe po yung kanyang behavior. Okay? When you apply a compressive load to it, okay, ang tendency po niya is to have po yung bending. Okay? So, nagkakaroon na po siya ng buckling or bending. Okay? Yan po yung ating intermediate column. So, what you need to do is to consider this buckling failure. Okay? When you design the member. Okay? Again, ang uunahin muna po natin is to determine the slenderness. Okay? It should be in between 30 and 120. Okay? To be called an intermediate column. And once you know na po na intermediate column po yung member natin, okay? So, may kasunod na po yun na procedure on how you decide, okay? So, you decide the member if it's an intermediate column using po our two theories of failure. Okay? So, meron po tayong tinatawag na theories of failure. Okay? So, ano po yung dalawang theories of failure? So, ang dalawa po is J.B. Johnson and then the other one po is the Euler. Okay? So, alin po yung, ano po yung ibig sabihin ng ating mga theories of failure po na ito? Okay? So, balikan po natin yung atin dati na stress strain diagram. Okay? So, halimbawa po, ari po yung stress, tapos ari po yung strain. Okay? So, gumawa po tayo ng ganito when we have our experiment, okay, on a tensile test. Okay? So, sa stress strain diagram po, say having ductile material, okay? So, mapapansin niyo po anong itsura ng stress strain diagram po niya. It is simply a straight line, tapos after po no, nag-curve, tapos ganyan po. Okay, tapos this is the actual, which is higher than the initial. Okay? Dito po, sa part na to, okay, your elastic limit, dito is your initial and elastic limit. Okay? So, ang tawag po dito, ito pong area na to, okay? So, this area po, the shaded area, yung po nasa leftmost, okay? This is your elastic zone. So, ang tawag po din is elastic zone. Ito naman kung nasa kabila, you call this the plastic zone. Okay, elastic and then plastic zone. Okay, so we say plastic zone. Okay, this is governed by the theory of failure known as the J.B. Johnson. Okay, at naman po kabila, this is governed by the Euler formula. Okay, so ano sabihin ng dalawang ito? Elastic zone, okay, say you have a member, you apply a compressive load to it, okay, it will deform, and then pag po na it will go back to its original dimension, original length. So, bumabalik po, kahit po siya nagkakaroon ng deformation, pag ina-add po natin yung load, okay, nagbabalik sa original dimensions po niya. Yun po yung atin na plastic zone. Okay? Ngayon naman po, we call it a plastic zone. Okay? So, plastic naman po, balik ka. Okay? If you have your sources, okay, you have your material. Yes po. Miss Janela.
Excuse po, medyo choppy lang po ang audio po ninyo.
Kailan? Simula kailan? Ngayon na lang.
Okay na po ngayon. Kanina po, nung sa, yan po, sa stress
Okay,
strain
medyo
tayo.
mahina kasi yung mahina kasi yung net dito. Nawawala. Okay, sige. Balikan ko, simulan ko ulit yung stress strain diagram. Okay? So, this one is a typical stress strain diagram for a ductile material. Okay? So, pwede po natin niyang hatiin into two zones. Okay? So, ang pinaghatian po nandun sa may elastic limit. Okay? So, ito pong nandito sa leftmost, yung pong shaded po yung region, this is called the elastic zone. Okay? At yung pong nasa right naman, so yan po at tinatawag natin na plastic zone. Okay? Ano po yung difference ng dalawa? Okay? Pag sinabi po natin na plastic zone, you have your material. Okay? Meron kang material. You put a load on it. Okay? So, ang nangyayari sa material, pag nilaplayan mo ng load, magkakaroon po ng deformation. Okay? O halimbawa, magkakaroon ng elongation. Okay? So, magkakaroon ng deformation. But then, when you unload, inalis mo na yung paghila mo sa kanya, what will happen? It will go back to its original shape, to its original dimension. Okay? Yan po yung elastic zone. Kung sinabi naman po nating plastic zone, kabaliktaran naman po iyon. Okay? Kabaliktaran. Ibig sabihin, when you load the material, it will deform. Okay? Pero, once na inalis mo yung paghila mo sa kanya, for example, inalis mo yung force na naka-apply sa kanya, it will never go back to its original shape or original dimension. Okay? A permanent set has been formed. Okay? So, yun po yung nandun sa plastic zone. Okay? So, that's the difference between the two. Now, the elastic zone, this is governed by Euler. Okay? Whereas the plastic zone, J.B. Johnson, siya naman yung formula to define this plastic zone. Again, for plastic zone, you have the J.B. Johnson formula. Okay? And for the elastic zone, you will be using the Euler formula. Okay, may question po? Wala?
Wala naman po.
Okay, so let me continue. So ito pong dalawa, the Euler at saka po yung J.B. Johnson, these are your two theories of a failure. Okay? Two theories of failure. So how do we design these members under intermediate column? Paano po ba siya i-design? So we start with general guide. Okay? Ari po, page 8. General guide in buckling. In designing a buckling failure. Okay? So, ari po yung susundin natin if we have an intermediate column. Okay? So, ano po ang unang gagawin? This would be your first step. Okay? So, compute the dimension by initially assuming that buckling failure occurs within the plastic zone. Okay? So, yun po palang una. Okay? Ang uunahin natin is to use the J.B. Johnson formula. Okay? So, ano po yung gagamitin natin? The J.B. Johnson formula. Okay? Um, ibig sabihin po, okay, ang ating assumption, failure is at the plastic zone. Kaya nga po ang ginamit natin ay J.B. Johnson. Okay? Failure is at the plastic zone. Yan. So, yun po ay simply an assumption. Okay? Kasi, yun po ang una dapat nating malaman. Nasaan ba ang failure? Is it on the elastic zone po ba? O siya po ba ay nasa plastic zone? Okay? So, to tell us, you will be using the J.B. Johnson formula. Okay? So, ang initial po sa J.B. Johnson, okay, failure is at the plastic zone. Okay? So, yun po yung gagawin. Okay? So, for the J.B. Johnson formula, you have here the equation. FCR equal to sigma y times A quantity 1 minus sigma YL squared over 4 pi squared NEK squared. Okay? So, let me go into details of this equation. Okay? So, let us have here sigma y. Okay? So, saan po makukuha yung sigma y? Hello? Saan po natin makukuha yung sigma y? Hello? Wala na? Yes po, Sir Dan.
Sa table at 7 hanggang 11 po ata yun.
Okay, so we have po our different tables and figures sa design manual po natin. Okay, so dun po natin kukunin yung value ng sigma y. Okay? O, baka po tayo masyadong nalito. Kapag po brittle, hindi po yung pinapalitan ng sigma u. Ang iba po kasi masyadong nasa ulo yung dibo natin. Okay, ductile yield, brittle ultimate. Okay, pero hindi po. Ito po ay nag-iisa pong equation. Okay, so whether it's a ductile or a brittle material, you will be using this equation. Okay, again, sigma y times A, quantity 1 minus sigma YL squared over 4 pi squared NEK squared. Okay? So, yun po ang malinaw sa atin. Now, so where do you obtain each of these values? Una, so you have here, sigma y nga po is a table. Yung A po natin, okay, yun pong A value, okay, it should be an equation po. Okay, so halimbawa po, kung siya po ay circular, then that would be pi d squared divided by 4. Okay? So, yun po yung sa area. Yung pong dimension natin, so doon po masosolve. Okay? Kasi kasama po natin yung A. Okay? Or the area. Same with this, sigma yl squared over 4 pi squared and ek squared. Okay? So, ito muna po nasa ilalim. Okay? So, 4 pi squared n. Okay? And then you have there E. Tapos po yung K. Okay? N, E, tsaka po K. Okay? Yan po yung unahin natin to sa mga component. Okay? Yung po L, E. Okay? E po is the modulus of elasticity. Okay, so this is modulus of elasticity for the value of K. Okay, so tingin lang po tayo dun sa modulus of elasticity from tables and even po doon sa manual po natin to use the standard. Okay, so the value of E po, dependent po yan sa type ng material. So, hahanapin po natin sa design tables. Kung wala po tayong makita doon, we can assume to use the standard value. Okay? So, yun po yung value ng E. What about po ng K? Okay, yung K po is the least radius of gyration. Okay? Yung pong sinolve po natin kanina, dinerive po natin, yun po yung value ng K po. Okay? So, yung K, kapag po circular, that will be D over 4. Okay? And then we have here N. Okay? Yung N naman po, ang tawag po dun sa N is N fixicity coefficient. Okay? N fixicity coefficient. You look at yun po nauna na pages dyan. Yan, page 7. Okay? So, yan po yung N fixicity coefficient N. Ano lang po ang pagpipilian natin? N equal to 1, N equal to 2, N equal to 4, and then you have here 1/4 to 1/2. Okay? So, yan po yung mga N values natin na ipapalit. Okay? When you say N fixicity coefficient, tingnan mo po yung magkabilang dulo ng atin na machine number. Katulad nito, meron pong guide dito sa taas, meron dito sa baba. So, N equal to 1. Okay, the second one, N is equal to 2. When one end is fixed, and then the other one is free, is a pin-ended or guided. 3, when both ends are fixed, your N is equal to 4. And yung last naman po, when one end is fixed, the other one is a free end, you use N 1/4 to 1/2. So, same thing, the value po, 1/4 hanggang 1/2, pare-parehas po na pwede natin gamitin. But then, for purpose po na pare-parehas tayo ng final answer natin, alin po yung gagamitin kaya natin? Just like the factor of safety.
1/2
Hello?
po.
1/2 po.
Okay, correct. So, we will be using there N equal to 1/2. Okay, we use the maximum value. So, pipili lang po tayo. Babasahin lang po natin ng maigi. Okay? Bibili po natin ng ano po natin. Okay? So, ang gagawin po natin, babasahin po maigi yung problem and then ano po ang sinasabi regarding the mounting ng ating member. Okay? So, saan po siya papasok? From A hanggang D. Okay? Then, tapos, saka po natin madi-decide on the value of M. So, tingnan niyo po yung ating mga illustration. Okay? Ano po yung sinasabi na both ends are guided. Okay? So, kumbaga, meron po itong guide dito, meron pong guide dito. Okay? So, initially po, you look at your member, it is initially vertical. Okay? So, tuwid po na ganyan yung axis niya. Okay? But then, due to the compressive load that you applied, ano po yung compressive load na in-apply po natin, ano po nangyari? Nagkaroon po ng buckling. Okay? Ari na po siya ngayon. Okay? na nakabend na po. Okay? So, yan po yung ibig sabihin ng backlink path. Okay? So, mapapansin nyo po, iba-iba po yung backlink path niya depende sa condition. Okay? Katulad po nito. Ang condition po nito, one end is fixed, the other end is free. So, ari po yung fixed end, ari po yung free end. So, ano nangyari? Nagkaroon po siya bending, tapos ganun yung naging itsura niya. Which is initially, tuwid lang po siyang ganun. Okay? So, same thing with this one, both ends are fixed. Yan, napag-ganon na po siya. Okay? So, deformations has really occurred. Okay? And makikita po natin that there is yung bending, okay, or debuckling failure. Okay? So, yan nga po ay common if we have a long, unintermediate column. Okay? Kaya sabi po dati, okay, ano po ang dapat natin gawin? You need to look first for the slenderness. Okay? Kasi pag pumatak po siya na long column, ganyan mo po siya i-consider. Okay? Kasi meron po siyang buckling failure. Okay? So, yan po yung mga values ng N. Okay? So, yan po yung sa-substitute natin dito. Okay? All of those will be substituted to obtain po yung F critical. Okay? FCR. Okay? Ang FCR po, ang tawag po dito is critical buckling load. Okay? This is critical buckling load. Yan. So, this is different po from FC. Okay, ano po yung FC? You call this the compressive force or compressive load. Okay? And compressive load, compressive force. But then if you have FCR, you call that the critical buckling load. Okay? And how do you obtain the value of FCR? Your FCR will be equal to FC multiplied by the factor of safety. Okay? So, hindi lang po yung compressive load. Kasi dun sa case 1 po, ang ginagamit lang po natin is FC. Okay? Yan po aring kanina. Okay? Ang ginamit lang po natin dito is the compressive load. Ayan po kapag nandito sa compression lang. Pero pag po siya ay intermediate column, hindi po FC yung gagamitin natin. But here, we will be using instead the critical buckling load, FCR. Ang gagawin mo po doon, again, your compressive load to be multiplied by the factor of safety. Okay? So, yung factor of safety po, doon po rin po natin kukunin sa table 1.1. And same conditions will be applied. Okay? So, yun po yung gagawin natin. Now, dito po sa JB Johnson formula, so isa-substitute po natin lahat ng value until we come up with a dimension. So, meron ka po diyang makukuha na sagot. So, saan po manggagaling ang sagot yan? Doon po sa area. Okay? Kasi gagawin mo siyang pi d squared over 4, for example. So, nandun po yung diameter. Same thing with the value of K. Okay? Yung K po na yun. Ano nga ba yung equation natin ng K? So, circular po yan, d over 4. Okay? So, it's a function of d din po. Nakuha po ba? Hello? Nasusundan pa po ba ako? Hello?
Yes po, ma'am.
Yes po, ma'am.
Okay? So, again, meron po tayo ditong naging sagot. Okay? Dimension po. Ang dimension, magmumula sa area, magmumula sa plane. Okay? So, may diameter po tayo dito, for example, na na-solve. So, ito po yung sagot natin. At tanong lang po ay, tama po ba yung sagot po natin na ito? Okay? So, yun po yung i-verify natin kung tama yung sagot natin ito. Okay? So, bakit po need natin na i-verify? Okay? It is because we started with an assumption. Okay? We assume that this is an intermediate column and we assume to use the JB Johnson formula. Okay? Kumbaga, assumption lang po yung ginamit natin na equation. Okay? Assumption then that the failure is at the plastic zone. Kaya nga po ginamit natin yung JB Johnson. Okay? So, ibig sabihin, yung sagot po natin dito, coming from the JB Johnson formula, okay, we are not sure if this is correct. Okay? So, hindi po tayo sigurado doon kung tama ba yung sagot po natin. Okay? So, ano pong gagawin ngayon natin? We need to check your answer. Okay? So, how do you check your answer? You use B over K squared criterion. Okay? So, para po ma-check po natin ang sagot natin, we will have the B over K squared criterion. Okay? Yung K po na yon, okay, yun po yung atin na least radius of gyration. Okay, yung pong K. Tapos kung siya nga po ay circular, then this K will be D divided by 4. Okay? What about po yung B? Okay? Ang B naman is equal to sigma y L squared over pi squared N E. Okay? So, lahat po ng value, okay, isa-substitute lang po natin dito. Tapos, you'll find the value of B. Yun naman po, K, o so, halimbawa nga po, circular, D divided by 4. Need po lang po ito ay K squared, okay? O, D over 4 kung circular po. So, in place po din sa D na to, okay, hari pong tinitest natin, yung pong naging sagot po natin dito sa JB Johnson, yun po yung ipapalit natin din sa diameter po na ito. Okay? So, kung ano po yung tinetest natin na value, yun po yung isa-substitute po natin doon. Okay? So, you'll have your answer. Okay? So, you solve for B over K squared criterion. Naiintindihan pa po ba? Hello?
Yes po.
Yes po,
Okay,
ma'am.
yung D po, again, yung D po, ang ipapalit po natin dito, yun po naging sagot natin sa JB Johnson. Okay, ano po sunod? Kapag po nakita natin that B over K squared is less than 2, ano pong sabi doon? Na-solve muna po siya, nakita mo po it is less than 2 ang answer po natin. Then we say JB Johnson formula defines or governs the design. Dimension stays. Okay? So, ano pong conclusion doon? Ibig sabihin, tama po yung sagot natin. Okay? It is really, failure is at the plastic zone. So, tama po na gumamit tayo ng JB Johnson formula. Okay? Kaya ang sabi po doon, dimension stays. Tama yung sagot natin. Kaya maglalagay ka doon. Therefore, use alin pong diameter. Yun po kuha natin doon sa JB Johnson. Kaya kung naman po yung nasunod natin dito, so yun po yung ano natin. Just convert it to the standard size. Okay? So, yun po yun. Kapag po ang B over K squared criterion is less than 2. Okay? If kabaliktaran naman po, it is greater than 2. Okay? If the B over K squared criterion is greater than 2. Okay? Ano naman po yung sabi doon? Then, the Euler formula defines or governs the design. Okay? So, ibig sabihin po, failure is not at the plastic zone, but rather it is at the elastic zone. Okay? Kaya ano pong gagawin? It is not correct to use the JB Johnson. Okay? What is more appropriate is the Euler formula. Kaya ano po ang gagawin mo? You need to recompute. Okay? Kanina dito, dimension stays kasi tama. Ngayon naman po, you need to recompute. Okay? You need to recompute the dimension using the Euler formula. Okay? So, and this is the formula. FCR equal to pi squared N A E K squared. Okay? Pi squared N A T K squared over L squared. Okay? So, kung ano po yung mga ginamit natin kaninang value dito sa JB Johnson, yun din po ang gagamitin natin dito sa Euler formula. Okay? Yun pong A na to, again, would be in terms of the diameter. So, ipapalit po natin dito, for example, is pi d squared over 4. Okay? And then sa K po, that would be d over over 4 ulit po. Okay? So, we'll have here po another answer. Okay? So, galing sa area, galing doon sa K. So, ari pong diameter na yun, okay, po ay galing sa Euler formula. Okay? Oh, ang tanong, tama na po ba yung sagot natin dito? Yes, okay? Kung ano po yung na-recompute mo using the Euler formula, this will be na po. Okay? You simply have to convert it lang po to the standard size. Okay? Nasundan po ba? Hello? Okay, so yan po yung procedure na atin na i-apply, okay? Again, sabit lang po ha. Again, uunahin po natin is the J.B. Johnson using an assumption, okay? Failure at the plastic zone, okay? So you use the J.B. Johnson. You'll have your answer, okay? Yung answer po nun, you need to check that using the B over K squared criterion. So sa K po, isa-substitute po natin yung tinetest natin. Okay, nasagot natin. Tapos po, pag nakita po natin less than 2 yung naging result ng criterion, tama yung sagot na yon. But then if it's greater than 2, then mali po. You need to recompute using the Euler formula. Okay? It simply means that yun pong ating failure is not on the plastic zone but rather andun sa elastic zone. Kaya ang dapat na gamitin natin na equation is the Euler formula. Okay? And whatever you have okay? So, question po, Andrej?
Ma'am, pwede pong baliktad sa, yung mag-a-assume ka muna po na elastic zone, yung Euler po yung unahin.
Again?
Sa Euler, sa Euler
Yes
po
po.
magsisimula.
Ulit po, choppy lang.
Ano
Sa
po,
Euler po,
magsisimula. I-assume po na elastic zone yung bulk buckling failure.
sa Euler po ay again,
Sa Euler po kayo magsisimula, ma'am. Tapos pag mali po, edi yung J.B. Johnson's po. Ang baliktad po niyan, kabaliktad.
hindi po. Lagi pong JB Johnson muna. Okay, so lagi pong JB Johnson muna. Okay, mali lang po sa kanya pag yung pong natin. Hindi po pwedeng baliktad. Lagi pong ganon. Okay na po?
Yes po.
Hello? Okay na?
Apa.
Okay. Okay. Any other question po? Hello? Wala na po ba?
Pero dito, hindi naman siya nahihiya sa akin.
Wala na po ma'am siguro po.
Okay na po, ma'am.
Oh, may tanong pa po? Wala na?
Wala na po, ma'am.
Okay. So, ang iba, okay, i-share ko na lang din sa inyo. Okay, ang question ng iba is, what if po, okay, this one, the criterion is less than 2, the other one is greater than 2. Paano daw po, ma'am, kung the value is equal to 2? Okay, paano naman po kung equal sa 2? Okay, so balikan natin yung illustration natin kanina. Okay, on the two theories of failure. Yan. Okay, ito yung sa J.B. Johnson, ito yung sa Euler. Dito po, yung B over K squared, ari po yung less than 2. Okay? Ari naman po, yung B over K squared greater than 2. Ari yung nasa Euler. So, when you have this line po, okay, yan po yung atin na boundary. Okay? This line po, your B over K squared, okay, yan po yung equal sa 2. Okay? So, ibig sabihin, kapag po na dito yung linya natin, you can categorize this as either elastic or plastic. Okay? So, preference mo na po yun kung alin po yung gagamitin po natin. Since, yun po yung ating pinaghatian. Okay? Nagkakaintindihan po ba tayo? Same thing with, okay, same thing po with, okay, case 1 and case 2. Okay, kung mapapansin nyo po, ano po yung boundary po ng dalawa. This is less than or equal to 30. Ito naman po, this is greater than 30. So, yung 30 po, yun po yung pinaghatian. Okay? So, ibig sabihin, kapag po siya ay 30, okay, you can categorize that as a compression block or an intermediate column. Kasi yun yung pinaghatian. Kaya minsan po, makikita po natin doon sa atin na sa mga books, okay, hindi rin nakalagay less than or equal to 30, kundi less than 30, tapos dito nakalagay or equal to 30. Kasi nga po, pwede pong din siya kagrupo or pwede din po dito sa case 1 po natin. Okay? Naintindihan po ba? Dahil po siya ay, yun po yung ating boundary ng dalawang cases. Okay? And then this is the last one. Okay? O, ito naman po yung huli. Yan. So, this time po, this is case 3. Okay? So, when you say po case 3, we call this po naman as a long column. Okay? So, this time po, yung value po ng slenderness natin, L over K, is greater than or equal to 120. So, ito naman po yung pinaghatian po noong ang case 2 with case 3, yung value na 120. So, yun po yung gitna ng dalawa. Okay? So, when the slenderness is greater than or equal to 120, you call it a long column. Okay? Kapag po long column yan, okay, the induced stress, okay, so ang induced stress po niya, okay, is somewhat similar to that of a pure bending. Okay? So, sa pure bending na po siya pumapasok. And if it's a pure bending, yan na po yung tinatawag natin as the bending stress or the flexural stress. Okay? So, for our equation, the bending or the flexural stress is equal to MC divided by I. Again, I pertains to the moment of inertia. M pertains to the maximum moment, which can be taken from your shear and moment diagram. Okay? And C will be taken from the different cross-section. Okay? So, yan po yung magiging flexural stress natin. Kumbaga, kahit siya po ay compression member, okay? So, ang nakikita mo na po sa kanya is more on a pure bending. Kaya, naging ito na po yung kanyang induced stress. And what you will do is simply, again, to equate the design stress to the induced stress of the material. So, therefore, your sigma D would be equal to your flexural, equal to MC over I. The design stress, this can be sigma U over Fs o kaya naman ay sigma Y over factor of safety, equal to MC over I. This is if design is based on the ultimate, okay? And then the other one, if design is based on the yield. So, pipili lang ulit po tayo dito. So, our dimensions here are nandun po sa letter I or nandun sa letter C. Okay? Nandun po yung dimension natin na isa-solve po natin. Okay? So, ito po sa case 3, hindi ko muna po siya ganon na i-detail. Kasi meron po tayo yung separate topic, okay, of machine members under pure bending. And this is similar po doon, okay? Kaya hanggang doon lang muna po tayo on the designing based on ultimate and yield and equating the design stress to the induced stress. Okay? So, ano po na itong column. That is case 3 when slenderness greater than or equal to 120. Okay? So, meron pa tayong additional po dito pag nandun na po tayo sa ano po natin. Okay? Doon po sa topic na yon. Okay? May question po sila? Hello? May question po? Hello?
Wala naman po.
Ma'am, wala naman po.
Okay, okay, okay. Okay, so ano pong ibig sabihin nito? Okay, so we need first to obtain, okay, yun pong ating slenderness ratio. L divided by K. Yun muna po lagi ang ating unang hahanapin. Okay? Kasi kapag po alam na po natin yung L over K, okay? So alam na po natin kung anong case. Okay? Case 1 po ba siya? Case 2 po ba? Or yung case 3? Okay? Kasi for each of those cases, meron siyang procedure na iyong i-follow. Okay? Nakuha po ba? Naintindihan? O, kaya dapat alam mo palagi kung alin ang anong compression member siya. Okay? Case 1 po ba? Case 2 at case 3. Okay? Kasi pag alam mo na kung anong case, nandun na yung procedure. Susundan mo na lamang po. Okay? Now, ang kailangan lang natin to determine yung case again is the slenderness ratio L divided by K. Okay? So, nandito lahat yung buhay mo. Okay? Nandito yung procedure na i-apply mo. Okay? You look at now at our slenderness ratio. So, hindi ka po makaka-start not unless, okay, you know the slenderness ratio. Para alam mo kung aling procedure yung i-apply po natin. Case 1 po ba? Case 2 po ba? Or case 3 po? Maliwanag? Hello?
Yes po.
Okay, good. Pero, tingnan nyo muna po yung ating slenderness ratio. Okay? L divided by K. L pertains to the length and K is the least radius of gyration. Okay? Equal to the square root of I divided by the area. Okay? Kung circular nga po yan, ano nga ulit yung K natin? D divided by 4. So, ibig sabihin, ang isa-substitute mo din sa K na yon, okay, this would be D over 4. Okay? Tapos ito, meron kang length. Okay? You look at yung K, it is a function of the diameter. Okay? Pero ano po ba yung hinahanap natin? Okay? Ano ba yung dinidesign natin? We are looking for the diameter or we are looking for the dimension. Okay? Di ba yun din yung sinolve natin dito kanina? Yan, yung diameter galing sa J.B. Johnson, diameter galing sa Euler. Okay? So, ibig sabihin, the diameter is unknown or the dimensions are unknown. So, how can you solve for the slenderness ratio? Okay? Yun ang una. Sabi ko nga kanina, yun ang kailangan mo unang malaman. L divided by K. Pero, ang tanong ay, paano ka makakasolve ng slenderness ratio? Yun nga pong K is a function of the diameter. So, can you find a value of the slenderness ratio? Yes or no? Hello?
Hindi pa po.
No po.
No. Tama. Hindi ka makakasolve. Hindi mo makikita na siya ay less than 30 o kaya siya ay in between 30 and 120 or greater than 120. Okay? Kasi unknown nga yung diameter. Yung K natin, okay, is a function of the diameter. For example, na siya ay circular. Okay? Kaya hindi ka makakakuha ng slenderness ratio. Okay? So paano pong gagawin namin doon? Sabi niyo po kanina, para po makastart po ng design, di dapat alam muna natin yung cases which are dependent on the slenderness. So paano po ako magde-design yan? Ayun nga po yung wala. So ano po ang gagawin? Hindi na lang po gagawin kasi mahirap. So paano nagkakalokohan lang yun, di ba? O ano po, kasi sabi natin doon mag start pero yun naman pala ay unknown din. Okay? So ano pong gagawin kaya natin kapag kaganyan yung case natin? Okay? So kapag po ganyan, ano po yung gagawin? Okay? O din na lang po ako magsusulat. Okay? So ano po yung gagawin? You start with an assumption. Okay? So ito po yung ating gagawin. Hindi po natin alam kung anong case. So ang gagawin po natin, we assume first intermediate column. Okay? So ano po ang unang assumption natin? Assume intermediate column. So ibig sabihin, ano pong case are? Case 1 o case 2? Case 3. Ano pong case are? Kung inassume po natin na intermediate column. Okay, tama. Case 2. Okay? So, nag-assume ka ng case 2. You assume intermediate column. So, puntahan mo yung procedure nung intermediate column nung case 2. O, paano mag-start yung case 2? Mag-a-assume ka ulit ng JB Johnson. Yan. O, di ba? Yun ang unang procedure sa case 2. Assume JB Johnson. So you use the JB Johnson formula. We are assuming that failure is at the plastic zone. Okay? So meron tayong nakuhang sagot galing sa JB Johnson. Okay? So aring sagot mo na yan. Now, tanong, tama ba yung sagot natin na yon? Yes or no?
No po.
Okay, so hindi pa po, no po, hindi pa po natin alam, okay? Kumbaga, hindi pa po natin alam, okay? So, para malaman, you need to check, okay? So, you need to check, okay, using B over K squared criterion. Yan. So, nag-check ka using the B over K squared criterion. If, okay, B over K squared, okay, halimbawa ito yung nakita natin. If B over K squared is less than 2, we say JB Johnson governs the design. So, anong sabi? Tama daw na JB Johnson. Can we use this diameter already? Can we use this diameter already?
Yes po.
Pwede ba natin sabihin na dimension stays? Ha?
Apo.
Yes po.
Hindi pa. Hindi pa po ulit tayo sure. Okay? Hindi pa po tayo sure. Bakit? Ang napatunayan lang po natin is this assumption. Assume the JB Johnson. Tama, JB Johnson. Pero, hindi pa po tayo tapos kasi may isa pa tayong assumption. Okay? You assume there an intermediate column. So, you need to verify. Kaya, anong gagawin mo? May pangatlo ka. Okay? You check using the slenderness. Okay? You use the slenderness ratio L over K. Okay? If it happened that this value, okay, ang gagamitin po natin K dito, okay, ay yung naging sagot po natin dito sa JB Johnson. Same thing din sa B over K squared. Yung naging sagot po natin dito. Okay, doon sa K natin, ang isa-substitute natin, halimbawa, diameter would be diameter coming from the JB Johnson. Okay? If the value nung nasolve mo din na slenderness is in between 30 and 120, tsaka mo lang sasabihin that it is really an intermediate column. Okay? Oh, and then you'll have your conclusion. Therefore, use the coming from your JB Johnson formula. Nakuha po yung flow? Nakuha ba yung flow ng solution natin?
Yes.
Hello? Okay. Oh, maggawa naman tayo ng yung isa pang posibleng mangyari. Yan. Hindi mo uli alam. Okay? So, you assume intermediate column, tapos assume JB Johnson. Meron ka naging sagot. You need to check using the B over K squared criterion. Nagkataon lang, pagdating din okay, o iliban natin din sa kabila ha, okay, nangyari ang iyong B over K squared, okay, happens to be greater than 2. Okay, ano sabi natin pag greater than 2?
Euler po.
Euler po, ma'am.
Calculator formula po.
So, Euler governs the design. Okay? Euler governs the design. So, you need to recompute. Okay? You recompute using Euler formula. Yan. So, magkakaroon ka ngayon ng bagong sagot. Diameter galing po dun sa Euler formula. Tama na ba yon? Uy,
Hindi pa
tama
po.
na o hindi pa? Hindi pa po. Anong ating gagawin? I-check po ulit natin. Okay? Alin ang gagamitin natin pang check?
Slenderness ratio po.
Slenderness po.
Slenderness. Tama. Okay? So, you go back again to slenderness. Okay? L divided by K. Yung K po na gagamitin dito, that will make use of DE. Okay? Yung diameter na po galing sa Euler, yun po ang isa-substitute natin din sa K. Doon sa B over K squared, alin ang sinubstitute natin? Yung diameter galing kay JB Johnson. Okay? Dine, at tinitest na natin ito. Okay? So, yung galing kay Euler, yun yung gagamitin mong K. Kailangan, yung L over K na yon again, must be in between 30 and 120. Okay? Hello? Okay. So, yan po dapat. Pag po nandito uli, yung nakuha mong slenderness, ano yung sasabihin natin? This is an intermediate column pa rin. Okay, so tamang intermediate column. Ano ang ating conclusion? Alin ang gagamitin na diameter? Alin ang
Yung sinulf
gagamitin na sagot?
Yung sinulf po by
Yung
Euler.
galing sa Euler, tama. Yung galing kay Euler, yun yung sagot natin. Okay? Yun yung pangalawang scenario. Okay? O, may pangatlo pa tayo. Ano yung pangatlo? Yun yung pinakamahaba. So, una, you assume intermediate column. So, you assume JB Johnson, may sagot tayo. Okay? Anong sunod na gagawin? You check. Okay? Din ulit tayo. Check. Using B over K squared. Okay? Greater than 2. So, Euler. Anong gagawin? Recompute. Okay? Nag-recompute ka. May diameter ka using the Euler. Okay? So, may sagot ka na, parang lang. Anong sunod mo doon? I-check mo yung sa Euler. You use slenderness. Okay? Oh. Ngayon, nung i-check mo to sa slenderness, L over K, dini sa K natin, anong isa-substitute natin? Itong diameter po na ito. Okay? Oh, nung ginamit siya ngayon natin, it arrive, halimbawa, naging less than 30. Okay? O ang na-compute mo naging less than 30. Hindi pumasok doon sa in between 30 and 120. Anong sasabihin natin? It is no longer an intermediate column, but rather this is what? A pure compression block.
Diyos ko, sinabi ng
Okay, so it's a pure compression block. Okay, so therefore, anong gagawin mo? You need again to recompute. Okay, recompute using particular case. So in this case, since it's a pure compression block, you recompute using the procedure for case 1. So you'll have your another answer. Diameter considering case 1, for example. Okay? At kung ano po yung maging sagot mo doon, therefore, you use that D1 already. No need na i-ano po natin yon. Hindi na po natin i-check pa. Okay? Kasi kung ano po pumatak dito, alambawa po, pumatak po siya na greater than 120, then we'll recompute using case 3. Tapos yun na po yung ating final answer. Naintindihan po ba? Uy.
Yes po, ma'am.
Okay, na-analyze po yung pong iba kaya. Okay, so try to analyze
Yes po,
po
ma'am.
kung paano yung procedure po natin dito ha. Medyo madami
Wow.
lang po. Okay, kasi we have case
Kuya
1
rin.
up to case 3. Okay, case 1 up to case 3. Okay, so pipiliin
Sino
po
nagkabedi
natin.
ka?
Okay na? Hello? Okay na po ba?
Yes po.
Yes po.
Okay, so case 1 hanggang case 3. Okay, so next meeting po, I'll have our sample problem. Okay, but then you may try na po solving for, ari po yung inyong isolve. I-try nyo po isolve po itong number 3. Okay, then tingnan po natin on our next meeting, okay, kung tama po ba yung nakuha natin na sagot. Okay? So, kung wala na po tayong question, stop ko na po aring aking presentation. And then, let us have po our attendance. Alma, pasuyo.
Olma? Very active si Olma.
Yes po, ma'am. Ito.
Sige.
Si Justine.
Open your camera.
Yun, si Olma.
Hinahanap ko na. Nag-attendance check si Sir may Sir Emil na ang hahalili sa akin. Sa ulo. Sa ulo na. Sa 6 na beses kong inuulit. Okay, game. Alma, game na.
Yes, ma'am. Hintayin lang po yung iba po ng konti. Okay po. Okay, 1, 2, 3. Isa pa po, ma'am. Okay po.
Okay,
1,
another one.
2, 3.
Nalit ako eh.
Okay,
Okay na po.
sige po. Bye po.
Thank you po.
Thank you
Thank you po, ma'am.